I'm Anil Kumar. Welcome to my series on trigonometry. We'll use inverse trigonometric ratios to find the angle when we are given the value of a trigonometric ratio. In this video, we'll use calculator and we'll also do questions without calculator. So first set of 4 is without calculator. And for these with decimal values, we are going to use the calculator. Now, while finding the angle theta, we'll use inverse of trigonometric functions. And on the calculator, we are only given inverse of sine, cosine, and tan. So the secant, cotangent, and cosecant, we have to first convert to sine, cosine, and tan, and then solve, right? Few other concepts which we need to understand is that the positive and negative values of trigonometric ratios, in quadrant 1, all are positive. In quadrant 2, sine is positive. In quadrant 3, tan is positive. And in quadrant 4, cosine is positive, right? So if we are looking for positive value of sine theta within theta greater than equal to 0 and 360, that means one full circle, sine is positive in two quadrants, quadrant 1 and in quadrant 2. So we'll get two solutions. For cos being negative, it is negative in quadrant 2 and quadrant 3. Again, we'll get two values. And for cotangent to be positive, it is 1 and 3. For cosecant, which is reciprocal of sine, if it is negative, then we are looking for quadrant 3 and quadrant 4, correct? So you have to keep in mind the quadrants in which each trigonometric ratio is positive or negative. Once again, in quadrant 1, all are positive. In quadrant 2, only sine and its reciprocal cosecant is positive, right? In quadrant 3, tan and cotangent, and in quadrant 4, cosine. That's why we wrote C. We'll also need special triangles to find solutions without calculator. So two triangles are very important to understand. One is 30 degrees, 60 degrees, 90 degrees triangle. So if this is 60 degrees, that one is 30 degrees, this is 90 degrees, then the ratio of the sides is 1 to n square root of 3. We could also draw another triangle which is 45 degrees and 90 degrees. Let me draw this triangle in the form like this. What I'm trying to say here is that if this is 45 degrees, then each side is equal, so the hypotenuse will be square root of 2, right? So that is how it is related. Okay. Now let's begin and see how to solve these questions one by one. So let's begin with sine theta equals to square root of 2 over 2. We need to determine the value of theta, this angle, where theta is between 0 to 360. So in the first case, you notice that sine theta is positive. Positive for us means that sine theta will have solution when the angle is in quadrant 1 or in quadrant 2, right? Since we know the rule, that is, all are positive here, but sine is positive in quadrant 2, tan in 3, and cosine in 4. So positive means we have solutions in these two. Always, since there are two solutions, calculator can help us find one. What we do here is we find the related acute angle alpha, which will be always in quadrant 1. So let's call this angle as alpha. So we say sine alpha, let it be square root 2 over 2. Then what is alpha? Alpha is equal to sine inverse of square root 2 over 2, right? Now from our special triangles, we know that whenever we get square root 2, we're talking about 45 degrees, right? So if these sides are square root 2 and square root 2, then the hypotenuse is 2, right? And that happens for 45 degrees triangle. So that means alpha is 45 degrees. Now if alpha is 45, what could be theta? That is how we are going to approach, right? So theta has two values. One, since it is positive in quadrant 1, equal to alpha, which is 45 degrees. And the other value of theta will be this one, right? So which is 180 degrees minus 45 degrees, right? Since this angle is 45. Is that clear to you, right? So those are the two values which are our solution, correct? So when you take away 45 from 180, we get 135 degrees. So we have two solutions for sine theta equals to square root 3 over 2 when theta is between 0 to 360 degrees, and the two solutions are theta is equal to 45 degrees and theta is equals to 135 degrees. So I hope the steps are absolutely clear. We are going to repeat these steps 6 times, and I hope by that time you will be a master in this working out solution for theta. Now the next example here, we are saying cos of theta is negative. Now coming back to our rule, all silver teacup, cos theta being negative means we're looking for a solution which is either in quadrant 3 or in quadrant 2, right? Here all are positive, here cos is positive. Now cos theta equals to negative half also means that we can look into a special triangle which has 1-2 ratio, right? Which is 30-60-90 triangle. So this triangle, if the angle here is 60 degrees, the sides are 1, 2 and square root of 3. So that really means if I am having alpha in a quadrant 1, we actually solve for cos alpha equals to half. Now that gives us alpha, the related acute angle, as equal to 60 degrees, right? Since what is cos? Cos is adjacent over hypotenuse, right? So important thing to remember is the ratio sine is opposite over hypotenuse, cos is adjacent over hypotenuse, tan is opposite over adjacent. So cos is adjacent over hypotenuse, 1 over 2 is for the angle of 60 degrees. That becomes our acute angle. So what is the principal angle in this case? So the principal angle is this theta and also that one, right? So basically it is theta is equals to 180 degrees plus or minus 60 degrees, right? In this case, since those are 60 degrees. So that one is 180 minus 60, this is 180 plus 60. So we get our solution as theta equals to 180 plus 60 and 180 minus 60. That means 120 degrees when you take away 60, and when you add, it becomes 240 degrees. Is that clear to you? Perfect. So that is how we are going to solve this question. Now let's move on and take part C and D. This time we will be working with sine theta equals to minus square root 3 by 2 and tan theta equals to 0. I would like you to pause the video, answer this question, and then look into my suggestions. I hope you must have got the answer by now. We have sine theta equals to minus square root 3 over 2. That means we're looking into solution in which quadrant? Well, we know the rule is something like this. So sine is negative in these two quadrants, correct? So we're looking for solution in these two quadrants. What we going to do? We'll find the related acute angle alpha for square root 3 over 2. So we'll begin with sine alpha equals to square root 3 over 2, since we want the related acute angle. So alpha will be sine inverse of square root 3 over 2. We don't need calculator to find this value. We can use our special triangle, right? So square root 3 over 2 means we're talking about 30, 60 and 90 degrees triangle. So that is the triangle 60 degrees. So sine is the ratio of opposite over hypotenuse. So for 60 degrees it is square root 3 over 2. And therefore alpha will be 60 degrees for us. Once we know that, we can find what principal angle is. This is this much, which is, we can write theta as 180 degrees plus 60 degrees, and the other one is this one, right, which is 60 less than 360, right? So theta is also 360 degrees minus 60 degrees. Is that clear to you? So the two solutions are 120 degrees and 300 degrees. Is that clear to you, right? So we get our answer as theta equals to 180 plus 60 and 360, and this is 240, I'm sorry. Okay, so 240, right? So when you add 60, you get 240 degrees and 300 degrees, correct? So these are the two solutions for part C. Now let's look into tan theta equals to 0. Well, directly you can write down this answer. We know within 0 to 360, theta is equals to 0 degrees, 180 degrees and 360 degrees, right? So you can do this using sine theta curve also. Sine theta can be shown like this, right? That's the sine curve. And you notice that sine is 0 for 0. It is 0 for 180 degrees and also for 360 degrees. Now tan theta basically is equals to sine theta over cosine theta. If I want that to be 0, sine theta should be 0. And therefore, theta is equals to 0 degrees, 180 degrees and 360 degrees. So that's clear, right? Now let's take more examples. Now we are moving into reciprocal ratios. Cosecant theta equals to minus 2. So when I say cosecant theta is minus 2, then what is its reciprocal? Sine theta is reciprocal, right? That means sine theta is reciprocal, so it is minus half. Now sine theta is minus half. That means we're looking for solution in which two quadrants? Well, sine is negative in these two quadrants, correct? That's what we're looking into. Okay. Now when is sine half? So what I could do here is, again, sketch the special triangle, which is 30, 60, 90. Now here this side is 1, this is 2, square root of 3. Sine theta is half means we are looking for 30 degrees. So that means we will first work for acute angle. This is this side, alpha. Sine alpha equals to half. From here and this particular triangle, we get alpha is sine inverse of half, which is equal to 30 degrees. Now, how about theta? So we're looking into two angles now. In quadrant 3, theta will be 180 plus 30 degrees, and this will be 360 minus 30 degrees. Clear? So we get theta as equal to 180 degrees plus 30 degrees, and theta is equals to 360 degrees minus 30 degrees. Is that clear to you, right? So that is how we are going to find two solutions for this particular question. Perfect. So cosecant theta equals to minus 2 can be worked out by its reciprocal sine theta equals to minus half, just as we did here. Now, we'll use calculator to figure out the solutions. Sine theta equals to minus 0.5151. Negative really means that we are again looking for solutions in quadrant 3 and 4. So we'll first solve for sine of alpha equals to a positive value of 0.5151. That means this is our angle alpha. Now we can use the calculator to find the angle alpha, which will be sine inverse of 0.5151. So, to use the inverse of sine function, shift sine inverse 0.5151 bracket close equals to, we get this alpha as equal to 31 degrees, correct? Right. So when this is 31 degrees, that means these angles are 31 degrees each. But when we are writing the answer, answer is theta, principal angle. So this is one principal angle, which is 180 plus 31. The other one is 31 short than 360, right? So we get the angle theta as equal to 180 plus 31, which is 211, and the other one is theta equals to 360 minus 31, right, which is 329 degrees. So these are the two angles for the given condition. So I hope these steps are absolutely clear, and you must have understood by now how to use calculator to find this answer. Perfect. Now, the next set of questions, which is the last question for this video, is for you to answer. So I'd like you to pause the video, answer this question, and then look into my suggestions. So here we have cotangent equals to 1.1917. Now cotangent really means 1 over tan, right? So I could write here as tan theta equals to 1 over 1.1917. So let's see this. So 1 divided by 1.1917 equals to approximately equals to 0.8391. Okay, let's write this. So that is what tan theta is equal to. Now, we're looking for positive value of tan theta. Tan theta is positive in quadrant 1 and 3, correct? Since you know the rule, right? So the cost rule. So tan is positive in quadrant 3 and in 1. So what we will do here, we'll again find the acute angle alpha, right? So we say tan alpha equals to 0.8391. Alpha equals to tan inverse of 0.8391, right? So we have shift tan inverse, and we have 0.8391 within brackets equals to 40. So we get this angle as 40 degrees. So alpha is 40 degrees, which is one of our answers. The other answer will be, one is 40, the other one is 180 plus 40, correct? The other one is 180 plus 40 degrees, which is equal to 220 degrees. Is that clear to you? So that is how we'll get solution of this particular equation. Now the last question for you. We'll now work on secant theta, which is positive. Positive means we are looking for a solution either in quadrant 1 or in quadrant 4, right? Now secant is reciprocal of cos. So that means cos theta equals to 1 over 3.8637. Let's find this value. So we have 1 divided by 3.8637, which is equal to 0.2588, right? So we'll find theta from here, which is also one of the solutions, right? So which is alpha also, as cos inverse of 0.2588. So shift cos inverse of the answer is equal to 74.99 or 75 degrees. So one of the answers here is 75 degrees. The other one is all this, which is 360 minus 75. So the other angle is 360 degrees minus 75 degrees, correct? So let's do 360 minus 75 to write down the answer as 285 degrees. So for the given condition, we know theta is equals to 75 degrees or 285 degrees. Is that correct? So that is how we have to solve for the angle theta, we say taking inverse of the trigonometric ratio helps us to find the angle theta, right? So we learned here how to find the angle using inverse trig ratio. Clear? I hope you understood and you liked the video. Feel free to write a comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.